All right. Well, thank you for coming tonight. We're going to be covering Talk Like a DBA, PostgreSQL. This is the first of 7 talks we will have on databases of various different kinds, unless someone else wants to come up and give a presentation. So, also when I first tackled this, I thought it'd be an easy topic to cover, and I realized that there is really just it can be covered in so many different directions and with so much information that we could spend a lot of time. I've tried to really pare it down to kind of just going from what is PostgreSQL and then how to apply it in a script and then into larger projects. So if you do have any specific questions, feel free to interrupt and ask at any time. It may be covered later on. I'll let you know. But if it isn't, I'm definitely happy to answer questions, specific questions. This is going to be more of a general overview of PostgreSQL and of how to interact with it in Perl. So basically, PostgreSQL, it's an RDBMS, or as Wikipedia said, it's an ORDBMS, which is basically an object relational database management system. Um, Basically, it's a database. It is it's ACID compliant, which basically means atomicity, consistency, isolation, and durability. Basically means once you've put data into it, it is there, it is available, and it should be correct. If your server dies, like right as you're writing things, the information is either going to be completely there or completely not going to be there. So that's a nice and a bad thing. In To really boil it down to a very, very short paragraph on this, it is a set theory-based system, which was first written about by Edgar F. Codd in 1969. It's basically a mathematical way of relating data with the idea of having tuples, basically unique pieces of information. The tuples will be your rows. The tuple has attributes, which is your columns, and those tuples are related together into a table. It's one relationship. So if you ever get into anything more mathy, you will run into those instead of rows, columns, and tables. So the history of PostgreSQL started in the 70s, like everything else did at Berkeley. It was called Ingress, which stands for Interactive Graphics Retrieval System. I didn't figure out why they called it that. It's just that's what it was called initially, Ingress. In '85, basically they had some people come and go, but they did an improved version. One of the lead writers of it came back, and they came out with the second, better, improved version. So they called it Post Ingress, or shortened it to Postgres. Then in '93 and '94, Berkeley ended the project because there was getting a lot of social requests for improvements, and it actually became its own entity up in the open market. They released it under the MIT style license, which is basically you can use it, just you have to have our copyright in there. And then in '94, they came out with Postgres 95. No idea why they called it that way, but it was basically the delineated. They removed the querying language, which was called PostgreSQL, and replaced it with the SQL uh, standard. And then in '96, 2 years later, they named it to PostgreSQL because of that. So that's just basically how you get from Ingress to PostgreSQL. Basically, the strengths of PostgreSQL. Obviously, it's been around a long time. It has been beaten, it has been tested, it has been tried, it has been added to. We'll get there in a second. Pretty much every major language has an interface to it, so you don't have to write it or figure out how to. You just need to get the SDK or the API. Very feature rich. It pretty much conforms to the SQL standard. It has the most advanced. Amongst the more advanced features are triggers, so you can do things in the database upon actions, and of course transactions. That helps a little bit with the ACID. And of course, there are many extra modules available. Basically, like you need to do fuzzy match, you don't have to write your own algorithm for it. It is a module that you install into your PostgreSQL, and you have a new command that does fuzzy match. It is a really interesting read. Also, the whole L tree idea, where basically, like with security, where you have people who have they belong to certain groups and they inherit the privileges of that group, and you can either come up with this unbelievably complicated way of associating a user with a manager with a group, or you just use an L tree where they are immediately, basically, you immediately search for them and they are immediately, you're told about the groups that they belong in. And it it really simplifies a lot of searches. If you come into something you think this is probably going to be unbelievably difficult to write my own, look into the modules that are available for Postgres. There's probably something that simplifies it. Kind of like in the Perl world, we have CPAN. Postgres has their modules. Weaknesses is it is a relational database, so it does have strict data types. This is not something where you can just throw anything into it. Well, you can throw anything into it. It's not what it's built for. It's not built as a key value pair. A while back, I was working at a company, and I needed something that was a little bit more durable than cache, but still a little bit more set in stone than trying to calculate heavy things up. And I literally created a table called a data, and it was literally just a key value store. I had chunks of text in it, I had calculations in it, I had HTML in it. That was just the wrong thing for PostgreSQL. But it'll do it, it just doesn't do it well. There are better solutions for that. It doesn't scale out well. It works. It's designed to work with one centralized beefy machine, maybe two with replication, but it is not meant to be used in a distributive manner where you have 30 nodes all with the same information.
It scales vertically, but not horizontally.
Exactly, it scales vertically, not horizontally. You can make the one node beefier as you need be, but if you want 30 of them so you have replication everywhere immediately, PostgreSQL not the best solution for that. And overhead. If you need to store something, if you need to store a list of months just so you can quickly figure out dates, you don't need the overhead of a database. You can put that in a flat text file and you have everything that you need with some very simple math. So those are the weaknesses of PostgreSQL. Not a lot, but they are there. So installing, there are two parts of this. There's, of course, installing PostgreSQL. This is on a Ubuntu system. You can download the source code if you want and install it that way if you're sadistic. I tried that for this presentation. I then abandoned it really quickly because it just took way too long to figure out. And it's been forever since I've tried to do it. And then from the Perl side, what you need is basically Perl comes with DBA. This is the database interface. Pretty much every major database module adheres to the DBA standard. So you have DBA for the interface. So when you're basically looking about what are the commands that I can use against my database, you will want to look at the DBA page. But the object that you're going to get back when you create a connection is actually the DBD PG. So if it was MySQL, you'd get the DBD MySQL. If it was, you name it, it'll be DBD that database. So you need both of these. In the past, I've installed these by hand. They can be a pain in the butt to install. So if you're looking to install your database, modules, try to find the ones that are pre-built for your system. Again, I did the Ubuntu apt-get and just installed the libdbdpg Perl. And it's done, it's much faster, and you don't have to worry about things getting in the way. So basically, from now you know basically what PostgreSQL is, how we get things started with it. Now we can get to the code, the good stuff. So basically, this is a VM that I have sitting on my laptop. I have PostgreSQL running on that VM. I created two tables just for ease of use. It's called score and student. Score is basically just a name, points earned, points total. Just real basics. Very bad database design. There are no IDs here. There's no relationship in between other than name and name here are going to be the same thing. But there is no, this is just a very messy, built database just so that we can poke around and see very bad behavior. So as far as connecting it to it, I'm just going to pull up the CPAN page. This is the DBD PG page, and it just tells us how we can connect. So basically, this is it. You want a connection to your database? This is the whole string. Basically, I'm showing you this here because my connection is just to a local host, a local database. So you don't see the fun thing of, oh, this is how you specify a unique host, a port, any extra options. We're really not going to worry about that. But the main thing is, when you do connection, this is all that you're doing here in your script. There we go. Is this line. So basically, we use the DBI module. Again, we're not specifying what database type not when we're using the module. So your program can be very agnostic at that point as to what it's doing. Here is the connection string. This is where the rubber meets the road. Basically, you tell DBI you want to connect, and here is where you tell it what database you're connecting to, what type of database. If this was MySQL, it'd be DBI MySQL. And DBI knows, basically, it goes to its connect method, which is then rewritten by the DBD PG module, and it knows, oh, I need to call out to this, and I get the appropriate object back for that module. And my DB name is Perl Mongers, and here's my username and password. Really good security right here. Normally, you'd want this in the config file, so it gets loaded in. You never see this, but we're just playing around, so who cares? And then, okay, so we have a DBH, our database handle. You'll see this in documentation. I know short names aren't the greatest thing, but you'll see this everywhere. So actually, DBH for database handle, STH for statement handle. It'll come over and over again. So basically, we have some data that we want to get into the database. And so what we need to do is we need to tell, PostgreSQL, or actually the database handler, here's our SQL. We're going to insert it into score, name, points earned, points total, values, and then, of course, we're quoting it because, the first one is a string. And then we're just popping in the integers, and those don't need to be quoted. It looks very pretty, doesn't it? It's, it's what we need for at this moment. So we go to run it, and we don't do the right thing, and we get a crap load of errors. And it's basically column Erik doesn't exist, which I don't understand. Fortunately, this tells me a lot information. It tells me it's dying right here. It seems that when you're quoting strings, it's not good to use double quotes. Strings need to be, hold on. Here we go. I just realized I left my notebook that tells me the order of these programs over here. Sorry. So basically, when quoting a string, you need to use single quotes for the database. So that's definitely important. Also, I added a little bit extra here, even though we already saw the error raised up. It's usually nice after you do, if you do or execute something, you want to basically, if it comes back with a 0, meaning it didn't work, you want to die with some type of an error, As you noticed, when I ran this, I got a whole mess of lines. It didn't stop on the first one. It printed the error and tried it on the second one, even though I'm doing the same thing over and over again. By adding in the die, it works. But if it would have died on the first one, it would not have continued on. That's where I missed my program. So this time, as we saw above, there were no score information, and now our scores are in there. It's not that bad. A pretty simple program. And the program that I missed was with error handling. And the idea of the error handling is this die. Also, we want to set print errors to 0, so it doesn't print the errors on its own. We want to handle printing the errors. You don't want a different program just to come out and say, oh, here's an error to your standard out, which is going to muck up your flow. It is up to you to say, no, I need to consciously tell you what I'm going to do with it. I got an error from this. I don't want to go to standard. Maybe you do want it just to go to standard out. Maybe you don't care that it died. Go ahead.
What are the double pipes?
Oh, I'm sorry. Yes, double pipes. This is an OR. So Perl executes everything in order. So basically, first it's going to execute from the DBH do to the end of the do, which is the end of this function call. and it's going to run this command, and it's going to come up with a return of this command. Now, fortunately for us, dbdo returns back either a true value, and I believe in an insert or in an update, I'd have to check the documentation. I believe it comes back with the count of rows that are affected. So here it should come back with 1, or if it doesn't affect anything, it comes back with the 0. Since it's 0, this basically follows your regular bash or command line theory that if this didn't work, well, then we're going to evaluate the other side of it. So Perl, if you have a conditional, which this in a way it is, it evaluates the first half of it, and if it doesn't need to evaluate the second half, then it won't. Since the first half came out as false, it says, oh, since this is an OR, now I need to look at this. And since here I'm dying, this is the end of the program, basically. So basically this reads of, do this, and if you fail, die with your error string. So I guess another way of writing it, this is a shortcut for basically this. My result.
Do or die.
Yeah, do or die. Yeah. And then, if result equals 0, then, die. So it's just a shorthand for doing it. So it's the beauty of Perl is it's Tim Toady. There's more than one way to do it. As you mentioned earlier, Derek, and as a former college professor once said, Perl is the language from hell, but the duct tape of the internet. And no single programmer can read another programmer's Perl code. But I don't believe that last one. So now we have it working. We have this wonderful program. It can insert. Now, obviously, we just have a hard-coded data because this is a demo. You could write it so it reads it in from another table. It asks someone for the information, and then they can insert it. And that's great. But that gets us to one major problem here, which is where the cartoon comes in. I should have timed this out. But it's basically little Johnny tables, or Bobby tables. It's basically son's school is calling to the mother, and basically they're having computer problems because when they entered his name, Robert semicolon or Robert colon drop table students, it basically dropped all of their records because they were not sanitizing their inputs. Now I really tried to get an example of this to work, but it really turns out that this is such an old problem that it is almost impossible to do using Perl's DBA modules. Basically, what this ends up doing is so what they were trying to do is probably pull up Robert's grades. Maybe they were trying to insert to Robert's grades, but what this is doing is basically stopping Robert's. It's saying whatever the command was, I'm stopping it with a single quote because remember, databases, the database needs a single quote, not a double quote. It ends the statement, and then it says, oh, here's the second statement. I'm dropping the table students. I'm deleting it. This can be very bad if you aren't sanitizing your inputs. This actually can be inserted into a database as long as you're basically escaping all these little characters that otherwise would be terminating a string. So the whole idea, and the whole idea with the sanitizing also makes life easier because you are basically taking out of your hands the need to properly format the SQL. So again, we have the data, we have my connection string, and this is how you write a sanitized query. Before we did a do, and the do basically says, I have a query, I just want you to do it. Nothing else needs to be done. Either you've hand created it, or it's simply something that can be executed without more information. So if we have a query that needs to have information added to it, this is what you do, is you write it out and you put question marks where the data needs to be put in. So you do a prepare statement, and so from the prepare statement you get a statement handler. And then in the statement handler you can bind data to each one of these question marks. And then we have, again, execute it, and if you can't execute, die and tell me why you died. And I see this all over the place. Java seems to love this bind parameter thing. But the greatest thing is no matter what these data values are, no matter what Unicode, whatever craziness they put in here, it will get escaped properly, so it can have no, basically it will always be strings. It'll comes out as a string that goes right into your database. It can, I don't want to say it can do no harm to your database, because I'm sure someone will figure a way around it, but this is a way you safeguard yourself. So I've always found this to be funny, and I'm sure someone can explain to me someday why this is a preferred way of doing it. I believe it's something along the lines of, if you bind this and then these values change without, basically, since these are references, and you're changing the values of these references as you're zipping through this, then you don't need to redo the step of binding. But in all honesty, well, you can write that code that way, and it'll be confusing, and someone, probably a new guy or a senior guy that's in a hurry, will see that and not figure out that, oh, these values are changing while this is happening, and misinterpret it and probably do something wrong. The much better way of doing this, oh, and just to show you that this actually works, we can, we'll run that. And then now we can see that we have twice the data in there, because I just reinserted it. Again, no, there we go. So let's look at a better way of using sanitized, of adding sanitized data. Well, now I just added a third set of data. We'll see a fourth in a second. So again, same exact program. We have our connection string. We have our statement. We create our statement handler. And now we just use execute. Basically, I have out of data here, each time I go through this array, I get an array reference. And basically, the array reference is 3 values. The 3 values happen to nicely align with my 3 question marks. So I basically just say, oh, dereference this array reference into the values and execute yourself. And that's it. You don't need to bind anything. You don't need to, if you remember with the bindings, you had to specify the order or the number it is. So if all of a sudden you change this and in the middle of this you added a new column, well then you have to go here, and in the middle of that you have to add another bind statement. Then you have to increment everything underneath it. Here you just, well, you really don't change anything. You just make sure your data coming in is the right number of arguments, and that's it. It works. So this is so much easier, and as I already showed you that I executed it, now we have 18 entries of the same data. So, you know, really, really great database right here. So these are great for one-off scripts, and basically this is what, you know, this is what you're going to be looking at. If you're writing a one-off script or a quick script, something, you know, just for your own amusement, you'll probably write it something like this, where you instantiate your database handler here. You create whatever statement handlers you need. You may, you may have three different queries, and you may call one lookup statement handler, one is insert statement handler, one is delete statement handler, and then your code will execute them back and forth, you know, erroring out where it needs to be. And that works great until you get into larger projects. And that's where you get into the idea of basically what's considered a DTO, or a data transfer object. To get to your data transfer object, you first need something that identifies with your table. So what I've created, I created score PM. So basically, in the Perl world, if it's a .pm, it's a Perl module. .pl usually means Perl script. I forgot why. But so as pretty much every, so we give it a package, a namespace. And then in it, we have it use DBI. Although this could be written in different ways, you probably want more of a base module to actually have the DBI connection, so that multiple DTOs, basically representations of tables in module form, can all use the same connection information. Because basically by hard coding this in here, if I have 50 DTOs and I change the password, I'm changing the password in 50 places. But again, this is just kind of to give you a flavor of how you can work into it. So the new does what new usually does, is it takes, it returns a blessed object, or a blessed data object. So in this case, it's going to be a hash reference. So it then knows that it's tied to this score class. And in it, I've added again, very rudimentary, an insert statement and a load statement. So basically now, instead of having to write out this insert query in my code, all I have to do is call and instantiate my score object. And I'll show you that here in a second. So basically, this is exactly, again, I kind of, I changed the data object a little bit to turn it into hash references, named value pairs, just so it makes it a little bit easier down below. And as you can see, I basically, for each entry in this data array, I loop through there and I call new on my score object, the score object which I included there. And so, like what the new does is it creates the DTO, it fills in, it says, oh, the name is Erik, the points earned is 50, and the points total is 100. And so then I call the insert method. Well, the insert method basically calls this, which basically says, okay, here's my SQL, and I'm getting it from, I'm preparing it through my database handler, and then I'm executing my statement handler with the object's name, points earned, and points total. So it makes it very transparent and very easy to see in the main code what I'm doing. And then just for the fun of it, at the bottom I say, okay, hey, give me a new score object called Erik, and load that object. So basically go into the database, find Erik, and let's print out how he's doing, which of course we already know he's doing pretty poorly. But there it is. So in this last run, we inserted the data once more, and as we can see, now we have 24 rows. And then we printed it out. So where did we get the 50 from? Well, I called, from my object, I call percentage. Well, I created, in my DTO, I created a little helper class because, who really cares about how many points you got unless you know what it means. So basically, when you call percentage, it just gets it shifts itself off of the arguments, and it basically says, oh, take my points earned, divide them by my total points, and multiply them by 100. Now, obviously, you'll want to make this much more robust, like, did we actually get anything back? Is this a 0? But again, you're doing this in one place rather than in all over your code. So that's pretty much it. I mean, from that, you can build up for every table, you'd build your own DTO, and then instead of having to, have SQL in your actual program, in your scripts itself, you would just have manipulation of these objects. That way, the primary idea here is to remove what data source you're using as far away from your actual code, so that if you decide to go to another database, it's easier to do because you just have to alter your DTO objects. Again, if you were just moving from PostgreSQL to MySQL, the damage is probably very minimal because they're very similar. But if you were going from PostgreSQL to a flat text file, a lot more code is involved. But again, you're only touching, those few files.
Or Oracle.
Yes, or Oracle. That again could be rather painful. So earlier said one of the ideas of PostgreSQL is ACID. And basically that means that the best thing is transactions in PostgreSQL. And so far, I don't know if you've noticed, but when I have created the database handler, I've always said auto commit is 1. That basically means the minute that you do it, commit it, which that may be good for the most part, but if you have a multi-step process, this may be a problem. If you're in the middle of a multi-step process and the computer shuts off, then, well, you have half-committed information. Or if, let's say, you're working in a network you're assigning IP addresses to machines, and you've said, oh, here's the IP address that I'm going to use, I'm associating with this machine, now let me go install it on this machine. Well, you've already done the database query to insert it, because otherwise someone else might snag it while you're trying to set it up. The process that goes out to say, let's say it never comes back. The machine isn't up to begin with, isn't reachable, it died. Well, now all of a sudden you have an IP assigned to a machine which never got assigned, so you're basically holding an IP which isn't being utilized at all. if you are doing it in a transaction, you can say, oh, this, this second step didn't work. I'm rolling back this transaction. Basically, I'm making it as if nothing ever happened. Of course, with the auto commit, that well, you'll see you can actually overwrite that. But that's where we go with transactions. Is well, here this is a different example. This is the idea of now we have another score, and I didn't introduce the other table, which is student. And this is where we get into bad database management. So in student, we have a student named Erik. It's me. And Erik has scores. That's great. But now we want to add in another student, and unfortunately the student's name is also Erik. And we're going to do it in a really stupid way. We're going to insert his scores first, and then we're going to insert him into the student table. The one thing I didn't tell you is I actually did something good with the database. I made this a unique key. So hopefully you see what the problem here is. I make my database connection. I turn on auto commit. I prepare my two statements because I have a score statement handler and a student statement handler. I've done the right thing. I've sanitized my inputs. I have my score data here, my student data here, and then I execute my score. And of course, it's not going to die because it's going to insert it just fine. And then I'm going to execute my student statement handler. And that's going to have a problem because I have a unique constraint on that. And there we go. Unable to insert new student. Error. Actually, hold on. Let's do this first. So I'm kind of just for this, I'm resetting the database so that we only have the 6 rows. So now let's not clear the scores.
Do we need to know what's in the students table?
Oh, the student table is unchanged. It does. Yeah. Thank you. But students table just is still me. I'm the only student. So transactions needed. So it says, I'm unable to insert new student. Error. Duplicate key value violates unique constraint, key constraint. It even tells me what the key constraint is. And that's really great. The big problem that we have with this though is, well, we still have the one student, but unfortunately we have scores. This is why you test things before. Nope. Yeah, there you go. We do. I'm sorry. I missed it. I was expecting a big jump, another 6. We do have another Erik score, but this is the wrong Erik. And we don't have his information either. So we've run into this problem. Something happened in the middle of this multi-step process, and it was interrupted, but we didn't do a good diligence. We had no transaction. So when our second query died, our first query stayed. And that's bad. There's no cleaning up. And you really don't want to try to clean this up. You don't want to try to keep a register of what have you already done so that you can literally undo it, which in some databases you might have to do. Fortunately, with PostgreSQL, you have the idea of transactions. Now, as you notice, it's pretty much the exact same script, same score, same student. I even keep the auto commit still on. This is the wonderful little line here, begin work. Now there are 2 things that can happen here. If auto commit was set to 0, which I believe by default, if you didn't provide this, auto commit will be set to 0, then you wouldn't need to say begin work because without auto commit on, it automatically puts you into a transaction. If you don't know what the state of this flag is, because probably in your program, you aren't going to have your connection string right above you, just start with begin work, because if it was in auto commit, it turns it out of it, and it starts your transaction. And then it does the same thing. It prepares, and honestly, we really wouldn't need to begin work until we get down here. But it does a prepare, and then it executes the scores, and and I still have the or die, and it executes then the student one. So what happens here is once there's a problem, and that's the eval. So inside the eval, when these die, instead of actually crashing the program, it'll just populate the $@ symbol for us, and and $@ will be the reason for the death. And then that allows us to gracefully exit out of here. Now, if I didn't have the eval, then this really wouldn't have mattered at all, because if your program dies and you're in the middle of a transaction and you terminate the connection, then it's just over with. The transaction just disappears. It never gets committed. Transaction only ends when it hits this line. But bad example because it's dying and this is the end of the program, but let's say you have another 50 lines of something else that needs to go. Your GUI expects a response, or just because it didn't work this way, there are 5 other ways you can try it. So that's why I've isolated it here. I'm saying, well, if it died, in other words, if I had a problem, then I can say, oh, something went wrong, I'm rolling back. That way you can roll it back, make sure that your database is in pristine shape, you didn't screw it up the way we did earlier, and you can go on with your other statements. If there was no issue, then you can just commit it. You can say, okay, now I can go on with my life knowing that I've added my new student and I've added his new scores. So here, we can do the same thing. We'll just clear out the scores and add in the old scores. But this time, with the proper transactions, it says, oh, something went wrong, I'm rolling it back. And if we're looking at our table, since I reset it, so that's the old way where we had the original scores plus the bad one, and I cleared those out and reset the original scores, we'll see now we just have the 6 rows. Even though in the transaction we've inserted the new row, the transaction was never committed. It was simply rolled back. So this is all great and good. We have transactions, which are phenomenal. Now we can make sure that multiple steps happen all together or they don't happen at all. We have a way of putting, instead of having all this mess in here, we can isolate that out into into modules, into DTO objects. You might run into this stupid idea. Okay, if once we're in our DTO, well, I did it anyway. So I'm in my DTO, and this is great. I'm going to have like 50 of these. I'm going to have one for score, I'm going to have one for student, I'm going to have one for this. Each one's going to have an insert statement. I don't want to write this every time. Heaven forbid if, for whatever reason, SQL changes, which it hasn't really changed that much, at least not the insert statement, in at least the basic version of the insert statement since 95. I don't want to have to rewrite this. And trust me, trying to figure out how many question marks, this works really great when there are only 3 values. But if I have 10 things that I need to insert, then I need to count out 10 question marks. It's just absolutely crazy. So you'll probably see what I used to write is something like this. So you have a base module which your DTOs will inherit from, and it implements insert. And it basically says, just give me the table name and your data in a hash ref, and I will create the insert statement for you and execute it and then die. And then after you've written this and you've used it for a year, you realize, oh, I just like the statement back. I really don't want you to execute it just yet. And then you're rewriting it and you're rewriting, it gets messy. Wouldn't it be great if something like this already exists for you? Well, it's a wonderful little module called SQL Abstract. Unfortunately, I didn't write any examples of it because that gets even crazier. But just realize if there's something you want to write in SQL, you really don't even need to have anywhere in it any plain SQL language, because SQL Abstract will easily take any crazy data structure, as long as it's done correctly, and translate it into the right where clause and give you back a statement that you can simply execute on your own. So that's part of the problem. The other problem is, who wants to create for every table? Who wants to create this? And then, oh, well, okay, so I just took it by faith that you're going to pass in, when you create a new score object, that it's going to have a name and it's going to have a points total and a points thing. But there's nothing in here that says it has to happen. There are no accessors. I'd have to write them out. I have to write them for everything. That becomes tedious. Well, you don't even need to do that. There are 2 wonderful modules called DBX class and class DBI, which you can choose them, and basically they take the headache away from you. So I'm just going to give you a quick slide. That's not a slide. Quick slide that shows something that I did in one of my personal projects. And this is basically what class DBI has for you. I have a filter on my screen. I have a table called auto user car. Basically, I'm trying to build a little, take care of the maintenance on my car, keep track of it. And I have to put auto at the head of each table because I don't own the database, so I can't create a new database for myself, so I can only create more tables in my current database. So anyway, it has all these fields. So instead of having to write my own DTO objects where I say, okay, this is an ID, it's a user ID, and it's an integer, and it's a this, I use basically class DBI. Now what you can't see here is an auto-based DBI. That's actually where it gets instantiated. And this is where my data, well, obviously DB, this is where my database connection happens. So all of my objects, all my DTOs call from that. And basically all I tell it is that I have this namespace called auto-user-car. This is the table name. You still have to tell it that. But here are the columns. And you can get pretty fancy with this. You can say these columns are write only, these are whatever. You can also tell it, hey, this user ID here, it points to auto user, and class DBI knows what your primary key is for an ID, so it knows through this that user ID in the user DTO points to the ID field. So basically, and it also has a car ID, which points to my auto car DTO. It has many maintenances, which is the auto maintenance DTO. These are all basically representative of other tables in the database, and these are the relationships between them. So basically in this little piece of code, and these are just little helpers that I made, you'll see that in a second, I've been able to describe what is my database, what are their relationships, oh, and you get to help me out with them, class DBI. So, oh, I did leave that down there. But basically it allows me to write something like this. From, my auto user car, search on it for this user ID, all the cars that belong to this user. And then basically, give me one of the instances of user car, and like user car, give me the car. So it gives me the actual car. This is the car DTO. This is basically pointing to my auto car data entry. And from it, I can get my description of my car. I can get the make, the model, the year, the engine. I didn't have to write a big query saying from my auto user car, select make, model, year, plus this, plus that. I just say, oh, just give me all the user car entries to this user ID, pull out the car, and then give me this information. So basically, through class DBI, SQL abstract SQL, the other module that I mentioned earlier, you can basically remove all of that fairly far away from any of your real code. Your code becomes more readable and much more maintainable because all of the parts where actually the rubber meets the road is just going to be in those ETO objects and not in your working code. So if you need to change the base of how you're relating to your data, it's again in that very small layer right there. So I realize that most of this really should apply to any databases. This was PostgreSQL, so this is more about structured databases where data is fairly normalized. Again, like this is cars that belong to individual people who have individual maintenances, although I didn't show that there. There we go, that have maintenances and distinct services. But definitely with this, you can connect to pretty much any type of relational database. So anyway, that's Perl and PostgreSQL. Any questions, comments, ridicules?